This video describes a reimplementation of the paper Connecting Language and Knowledge with Heterogeneous Representations for Neural Relation Extraction. Knowledge bases require constant updating to reflect changes to the world they represent. For general purpose KBs, this is often done through relation extraction. One way to improve relation extraction is to use KB embeddings for link prediction. However, despite clear connections between RE and KBE, very little has been done towards properly unifying these models systematically. So, what this paper does is it attempts to bridge that gap through a novel neural RE framework that learns language and knowledge representations jointly. As you can see in the figure, it gives an overview of how this method works. This method has a backbone, which is the BiLSTM for BiLSTM network with multiple levels of attention to learn representations of text expressing relations. Joint learning is guided by three loss functions, one for the language representation, another one for knowledge representation, and a third one to ensure that these representations do not diverge. In effect, this contributes to the paper's generalization power by preventing overfitting by either model. So finally, after all these dissimilarities have been gathered, they finally compute an overall loss, which we'll see right now in the code. So I'll show you the implementation of the code now. It takes a little bit of time to start. As you can see, as the number of steps keep increasing, the loss keeps decreasing. So it attempts to finally converge all the losses and minimize the overall loss. The original number of steps for this were 80,000, which for the purpose of the video I reduced to 500. So it will keep on going, and finally we see that from a loss of 17.64, it has finally come down to 10.5 or 4 right now. So as I mentioned before, as the number of steps keep increasing, the loss will finally come down to a very, very low number. Thank you.